Stephen, it's good to have you back, buddy.
Always good to be back. It's now the third time.
Third time on here?
Mm-hmm.
Folks, we're here with Stephen San Juan of Rise Renewables, third time guest. Thank you very much.
Thanks for having me.
I think this is cool. We're getting some repeat guests.
Yeah.
Huh? That's working out.
Well, it's good that you have the contacts list and enough good conversations to warrant coming back to.
Yeah, that's good.
I know there's never enough stuff to talk about sometimes. So
yeah, and I think we're 50 episodes. I'm going to go ahead and share some numbers.
Mm-hmm.
So I think it's months since I've looked at the data because I just don't. But we were months ago always over 35,000 views a month. And so now we got to be pushing 40. And Jacob tells me we have one on some TikTok that's 25,000 views. Some of these shorts. So these shorter ones people like. And I'm guessing they're technicians because it's like technical talk or something that's relevant to their job types. Yeah,
well, and it's kind of that you get to catch the buzzwords, you get to catch the catchphrase or whatever it is, and it's like, man, that's really good. It's really impactful. I know I watch a bunch of them too. So,
you know what? It was Tyler's. It's Tyler's. He was talking about a megger. Don't call it a megger. It's a insulation resistance test. Megger's a brand.
I wonder who taught him that.
Yeah, responsible for this one.
I was. But yes, it's one of those things. It's the age old, Kleenex versus tissue or anything like that. And it's not like it's going to end the world if someone calls it a megger. Everyone calls it a megger. I was at Fluke headquarters and we were calling it a megger up there, or a megger test up there. So it's just kind of one of those things where it becomes industry standard.
Right.
Everyone knows what you're talking about.
Yeah.
But it is still good to hammer home the correct verbiage. What is it actually called?
Mm-hmm.
Accuracy is usually good. So.
Well, as you guys have been preaching it, right? You teach more of the technical information and people get safer.
Absolutely.
So let's not cut corners.
Yeah, it's funny. I was actually just having that conversation this morning. We have a guy that's, teaching. He's coming in early, just really passionate, wanted to learn more. And I was like, feel free to come in early. I will come in early with you and answer all the questions you got. And this one actually might be controversial, but I will ask you, because you've obviously been on projects all around the world.
Okay.
When you are switching a pad mount transformer with a shotgun stick or an insulated switching stick, which direction do you face? Towards the transformer or away from the transformer?
Well, Anna got me on this one. So, no, I would never face towards it. And would always turn my head away the moment I switch, including the other bad habit of even breakers that reach in and place my hands where I want them and fingers, look away and switch. Always. But this was like, if I remember right, I did a lot of commissioning. So this was like the commissioner's instruction. You're the first one switching it. So if there is a short, you're going to find out. So look away and protect your eyes.
Yep. And I have heard this, and I've heard this over and over and over again, and it comes back to, it sounds good. It's like, well, I want to save the moneymaker, right? If I'm going to have something burn up, well, I'd rather have the back of my head burned than the front of my face because I'm a handsome individual.
There you go.
At least you are.
Aren't we all?
But I have sat in classes from incredibly knowledgeable technical instructors, and they teach this kind of face away from the danger. And I think at its root, it has this inherent mistrust in our personal protective equipment. And so I'm sitting there with the student, and funny enough, he's in our class with Tyler, and his dad is in a class over in Texas. I won't tell you where. But so both father and son in training, different companies, different instructors, getting conflicting information. So the correct solution is, well, let's ask. How do we know which direction? You're giving me this piece of information. I'm getting another instructor who is every bit as credible as this schoolhouse versus that schoolhouse. So who do I know that's right? How do I determine what's right? I know one of our favorite things to say all around the shop is RTFM, and I think I actually heard you say it on a previous podcast. RTFM, read the factory manual, or for you PG-13 folk,
right?
Do the math. But yeah, so I was actually able to open up, the actual manufacturer documentation and say like, hey, this isn't me saying it. This isn't Stephen San Juan saying it as much as I am saying it in classes. I'm actually getting it from OEM material or manufacturer's documentation or NFPA or OSHA or ANC or ASTM or any of these other 3, 4, and 5 letter agencies. There actually is documentation out there that can show it. And now it's not, let's me and you argue, it's argue with the federal government.
Yeah. So many of us, definitely for me, if there was such a thing, I didn't know about it, I didn't see it. I learned from the expert that was going to take me out and teach me.
Which goes back into...
I hoped he was an expert.
Yeah, hope he was an expert. And some of the best skills that I have were from on-the-job training. I can think back to my mentors throughout my technical career, whether it was starting in the Navy, whether it was my first couple of years in the industry, and I still talk to a lot of those guys and, give them credit where it's like, I would not be where I was at if it wasn't for those mentors to show me the good stuff. But with all the good stuff they showed me, there was a lot of bad habits there. So it's kind of... call a spade, hey, there's this amazing technique I've got, and this other technique that, probably never should have gone with that one. But we didn't know any better at the time. So.
And we just learned it's generational. Now, looking away, Anna really drove this home where I was wrong and she was right, and peace, you are. But it's not horrible either, right?
Yeah.
And it's an old joke I used to say too. And a little girl asked Mom, why do you cut the ends off the ham before you put it in the oven? I don't know. My grandma always did. Let's ask Grandma. Why do you do that? I don't know. Great grandma did. So we go find great grandma. Why'd you do that? She says, well, honey, my pan was too small. Right? But you learn this way, and the ham comes out great, I suppose.
Right. And yeah, the ham comes out great because, there's other factors that go into it. I would rather have someone fully suited up in PPE, wearing the appropriate or using the appropriate insulated pole to do the switching and face away than to be in shorts, flip-flops, and, switch the oil switch with a screwdriver. There's levels of wrong. There's technically wrong, and then just blatantly you're going to hurt somebody or yourself wrong. So facing away from switching is more technically wrong, but if you're doing everything right, wearing everything correctly, it's okay.
Right. But I don't remember what Anna said, but she brought up factors like face shields and blast directions and all of these things that are designed for you to stand with the front of your body.
Absolutely.
Facing that way, right? Which makes sense.
Well, and it also goes into, funny enough, I'm actually going to do a lecture over in New Jersey with a engineering firm. And they got a bunch, some of the smartest people you'll see in the industry. These are the ones that are designing projects. They're the ones that are, doing the arc flash analysis. And it was interesting because they reached out to us and said, hey, look, we understand all the math. What we don't understand is the practical application. We want to know, cool, I can see this on a print. I can write the print. I can make sure everything works from, voltage and current and kVA rating and design, and we can pick our equipment out. But what does this mean for my technician in the field? What are they actually now going to have to go see? And I was like, man, I wish more engineering firms would do this kind of thing of, I will go and talk to you forever to make sure that you make it easier for the technician in the field. And a lot of it comes down to is I understand what PPE I have to wear. I understand that there's a face shield and there's a balaclava and there's safety glasses and there's a flash hood and so on and so forth. But what I may not understand is what does it mean to wear all of that equipment when it's 120 degrees outside? That's my phone.
Oh, that's all right. When it's 120, right?
Yeah. And
now time, temperature, time.
Yep. And so good friend, Joe Chacon, one of his big things is how do we make it safer so that you don't have to wear the PPE? Right. Not because the PPE doesn't work, but when you're wearing that PPE and it's triple digits outside, the day's 18 hours and I have to put this thing on most of the day. And I just flew across country. I'm in a new climate, maybe not as hydrated as I should be. If I don't have to wear the PPE, I probably shouldn't wear the PPE. Not because it doesn't work, but because environmental hazards are real. So there's so much that goes into that. And it's funny because I love Anna, I love Tyler. They are some of the best at what they do in this industry. And we actually sit around the office and geek out about some of this stuff sometimes of just what is this situation? What is the correct way to do it? And we'll have students that come in that are very knowledgeable in their own right and say, well, on this project over in Alabama, we did it this way. It's like, oh, that's interesting. Why did you do it that way? Was it correct? Was it incorrect? Was it a unique case for this particular environment or job site you were on or equipment you were working with? And yeah, it's fascinating stuff.
But still safe ways?
Yes.
Even though there's variances in how because of where or when maybe?
Well, and what, most of my career was in the Southwest, California, Nevada, Arizona. I've traveled all over the country to commission, but probably good 75% of my work was kind of in this area. Well, how you mitigate hazards in the Mojave Desert is very different than Georgia, Alabama, Florida, the swamps of the country, or the Northeast when it's, 10 feet of snow on the ground, before 8 a.m. It's very different hazards that you're dealing with. Same thing going into other countries. I've commissioned sites down in Mexico where, okay, I know what I'm doing. I know what I'm doing, with my eyes closed, but now the crew I'm working with doesn't speak English. So how do I explain to them the work process, the scope, the safety, the job brief that we need to do when there's that language barrier? So it's fascinating where there's almost never a one-size-fits-all safety solution.
Right. Which is why we want to train people to be experts in their space so that they can create the safe process when they run into the unusual variables.
Yeah. And actually a part of our new to industry program has 2 full days on job planning. And it's one of the most fascinating things. And so far everyone that's taken it is like blown away. Because when you first say we're going to do 2 days on safety and JHAs, and they're like, I've done JHAs. I know what a JHA is. Why am I doing another one? Well, it's because there's all these different unique scenarios where exact same job task, different environment, different job site, different area, different region, can have drastically different safety hazards. It's been one of the most fun classes to teach because then once we give them the scenarios, now it comes into, well, here's this interesting scenario I've heard, I've seen or I've done or I've been involved with. And some of the pictures we get from students of planes crashing into job sites, after a hurricane or a tornado or an earthquake or, different wildlife they've seen on projects and all those kinds of cool things of like, I never thought about this before. So it's really cool that seeing the same old safety in a whole new light just because you change one little factor.
And then let them solve the problem.
Yep.
Give the scenario, let them solve for it. I love it. Yeah. Man, that's good training.
Yeah.
You say new to industry, but no, that's leveled up training.
Well, in the office right now, 2 students of Anna's, they're both safety managers, and they just went through this portion, and they're both saying the exact same thing of we learned something new. So these are seasoned guys that have been around forever. They have all the certs, they've done all the things, and they're still learning new information because I've never seen it that way before, never heard it put that way before. So always something new to learn.
They're safety managers?
Yep. Good safety managers.
Love it. Yeah. No,
yeah.
That's impressive, man.
Yeah.
That's impressive. You guys are leveling up.
We're trying to.
You're leveling up. You got some new classes to offer.
Yes. So those are our syllabuses for 4 new classes that we're offering. We'll be launching them Q1 of next year. This is our next step program. So we launched our new to industry program earlier this year, which is a 2-week program that says, hey, day 1 on the job, balance of plant. What does a basic maintenance technician look like? How do you do it safely? So this is what we're calling next steps of cool. I'm a new technician. I've done my job safely. I'm 1 to 3 years into my career. What do I do now?
Okay.
First one is an inverter course. So 5-day inverter course, which is really where my background came from. I worked for a large manufacturer. I've commissioned 1,000 inverters all across the country, Canada, Mexico, some in Europe. But how do you take all that away from a manufacturer-specific training and just take it to general industry? I think that is one of the large challenges in solar and battery right now is there's 1,000 manufacturers and they all do it a little bit different. What are the basic skill sets I need to approach all of those manufacturers effectively? It doesn't cover the manufacturer specific programming because obviously that would be their specific training, but it does talk about fundamentals of troubleshooting, how to read schematics, how to operate in and around inverters safely, what sources of power am I going to find regardless of the unit, how do I isolate, commonly across plants, all of this for a technician approaching the industry so that they can now go to any site and work effectively. That's not to say they wouldn't need manufacturer specific training at some point. But in my opinion, this should be the class that everybody takes before they go to that manufacturer-specific training.
What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today. I love this.
Yeah.
All of the isolated OEM manufacturer-specific training never made sense to me. Yeah. When I learned about how many different companies were out there.
Oh, it's insane.
And then how many companies were discontinuing models, discontinuing their entire business line,
right?
And then just not supporting, right? So then you have to leave it. So this makes more sense to me. Yeah. And I don't know. To me, the technology is not new.
No.
The technology is old. There's nothing too fancy about it. Maybe some newer components. But, you know, an H-bridge is an H-bridge.
Yep.
And control components are control components. Yep, you got your own secret software. But
yeah. And you mentioned the H-bridge. Like, IGBT technology has gotten a lot more efficient, but it's still an IGBT.
Right.
You still troubleshoot it the same way. You still replace it the same way. You still use the same, heat paste on it the same way. So being able to learn those fundamental skills and learn how to implement them, how to troubleshoot effectively. I can't tell you how many times a week I hear about, in a group text or a phone call of like, hey, I've replaced the, XYZ, ABC, UVW, I've replaced all these things. What do I do now? And it's like, well, have you tried troubleshooting? And so really trying to set those fundamentals of not just troubleshooting a specific cabinet, but the actual philosophy behind troubleshooting. When you approach troubleshooting, are you just, hey, there's a red light on that thing, so therefore I'm going to replace it? Or are you actually looking at your prints, identifying what all the possible causes are, identifying your most probable cause, and then effectively isolating it down to the actual fault, or just throwing a whole bunch of parts at it and hoping for the best?
Are you teaching how to read electrical schematics?
Yeah, that's a big part of it.
This class?
In that class?
Okay.
Yeah, so again, not manufacturer specific, although we are pulling in from manufacturers that we've done business with and all that kind of stuff, but it's not meant to be, this is how you read this manufacturer's schematic. It's the fundamental principles of reading schematics in general, both good and bad ones. Some manufacturers only give you a rough overview. Well, there's still a lot of information you can get from a one-page overview of that system. So how can you get the most information out of that page? And then all the way up to the manufacturers that give you, thick tomes of information and everything in between. How do I read this? How do I navigate it? How do I get the information I need to establish an electrically safe work condition, understand basic operations, and obviously effective troubleshooting?
It's fantastic. I just saw that now. It's module 4.
Yep.
Right. Is part of the test on that memorizing symbols?
I am not a big fan of memorization.
Formulas memorized?
So there are some formulas that we talk about, that we discuss, that we teach, but I've never been a big fan of memorization. In my opinion, memorization gets people hurt. Understanding where to find the correct answer.
Okay.
So obviously, with experience, with time, with repetition, you'll just know stuff. I mean, if I had to go off the top of my head and name component IDs or, navigate stuff, I, go to specific page numbers that I've gone to 100,000 times for troubleshooting. Sure, I've memorized that information. But if I didn't know where to find that information, I'd be in a world of hurt. Because when we memorize, we have this natural ability to assume that we know stuff that we don't. And maybe you've experienced this, right? Where it's like, oh, I know that piece of information, so I act on it. And then you realize, oh, I knew most of that information, but I forgot there's this really key part that I was supposed to do first. So that's why we always talk about what kind of information is available, how do I navigate to it, how do I read it effectively? Now, if you memorize some of that information along the way, cool, I love it. But you should know where to find those answers and verify those answers. Does that kind of make sense?
Yes. Yeah. Yes. You need to know where to go to find your answer.
Yeah.
Would never want to stop that.
Yeah.
So you're teaching problem solving. You're teaching how to research, how to discover, how to define your work process more than go memorize this sheet, these tables.
Right. Perfect example was, like I said, this technician that's been coming in early for the last week and a half or so. In his truck, his loadout, he has a Hioki meter. It's like the CM 473 or whatever the nomenclature is. We had the Fluke 87.5, which is, both of them are great meters. They do the job. They measure voltage, current, resistance, but they have different ratings. They have different abilities, different capabilities, different software, and all that kind of stuff. Well, if I have both these meters in front of me, how do I know which one I'm supposed to use? Is it just a preference? I like yellow versus blue. Or is there actually functionality with these two meters that I can or cannot use them in my application? And so we actually showed them RTFM. So we pulled up the manual because we have the manual for both and said, well, what kind of measurement are you doing? Okay, well, in this meter, you can't take that measurement because it's literally not rated for it. With this meter, you can, but you have to have this additional hardware in order to take that measurement. And here's the part number for it and all that. Well, I wouldn't ever ask them to memorize part numbers or specific tolerance bands for a meter, but you got to know where to find that information.
Sure. What about short-term memorization? Fan, not a fan?
I guess it depends on the context. Sure, if I'm on a project and I just understand here's the 5 steps I have to do and go do those steps, there's nothing necessarily wrong with that. But a lot of the times, depending on the context, that's where that complacency comes in. I'm just like, oh, I'm doing the same things I did yesterday and the day before and last month and the month before that. And now all of a sudden something blew up. Well, what happened? Well, you memorize those steps and you stop going back to that procedure and you just unintentionally, hopefully, you skip that step or two that was very vital to getting this done the correct way.
Yeah. Yeah, that refresh at the start of the job, you can't ever be skipped.
Correct.
Yeah, of the job planning. All right. Next steps, inverter, corrective, preventative, maintenance technician. What else you got here?
So that next one right there is an MVHV course. So everything about a pad mount transformer, how to work on it, how to maintenance it, how to repair it. So 5-day course. What is a transformer? What does it do? Why are they there? And then hands-on practicals for all of the basic corrective preventative maintenances you would realistically be doing. Everything from a cold weld to repair leaks to oil samples, how to actually pull those the correct way so you're not causing damage, replacing bayonet fuses or expulsion fuses, doing visual inspections, reading all of your gauges, troubleshooting your transformer alarm circuits, all of that with hands-on in the class to be able to do it.
Hands-on in the class. And these have a criteria, pass-fail, right?
Correct. Yeah, so all
80%.
Yep, so all of our written tests are 80%. We don't believe in the whole pay-to-pass model. We have failed students. And the more technical the classes, the higher our fail rates are. Our new to industry stuff is pretty high pass rate because it's basic safety. But our more advanced technical stuff, not everyone's built to be a troubleshooting technician. Not everyone's built to kind of have that troubleshooting mind. And that's not a bad thing. No. There's maintenance guys, there's troubleshooting guys, there's admin guys, and so on. So same thing with this. We actually have a criteria for passing all the hands-on practicals. So throughout the course, you have to participate. You have to show up every day. You have to actually do the tests. And yeah, pass the final exam.
Hazards, then it's what does it do? Looks like components, maintenance, preventative, corrective. Great syllabus, great class.
Thank you. I wrote the syllabus myself.
Yeah, I believe it. I believe it.
And actually, funny enough, on that particular coursework, understanding the arc flash label. Over the past couple of years, I've found that most people can give you a basic definition of all the components of the arc flash label. But when you actually ask them, like, so what does this actually mean for you on the job? Kind of get a blank stare of like, what do you mean? I just explained it to you. It's like, no, those are all definitions, but let's draw this out on a piece of paper. What does this mean if I'm standing here versus here versus here? And depending on what the label says, how does that change what PPE I wear? Or what tools I need to do this job safely, or can I do this safely? Do I have to isolate somewhere upstream, like, maybe at a substation, then come switch the transformer? There's a lot of that stuff in there that we do talk about in that class of when you're approaching a transformer that you don't know, how do you identify what PPE and how do you identify where you need to stand? How do you identify how to switch properly? Is this a load break disconnect or is it an oil switch? And what's the difference between those two things? So all that goes into it. That one's the one that I'm the most excited about, that we have the most kind of people asking us about, is MVHB, transformer maintenance, all that kind of stuff. So I think that's going to be a big one.
That is a big one. And you're talking about the energy levels, right? When you need the PPE, what type, where you should be, where you shouldn't be. And Joe will always probably tell you try to not be where you need it.
Yeah, that is the truest thing. Is you should always wear a seatbelt, but even better, It's better to watch the accident from a distance and not have to rely on the seatbelt.
Right.
So yeah, if something's going to blow up, it's actually, again, going back to the conversation I had this morning, I told my students, like, every single time I switch, I assume it's going to blow up in my face. And if I prepare for that, then guess what? If it actually does, I'm fine. I get to see something cool and tell a cool story in a podcast. Never been into arc flash myself, but
No?
no. Seen plenty of equipment failures, but never been actually standing inside of it. But again, if you assume it's going to blow up every single time, so what do I need to do to make sure that I'm safe? Never have to worry about it.
Yeah. Yeah, I've been in a few. I don't, even with the right PPE, that ruins your day.
Oh, yeah, I would not want to.
I can ruin multiple days. Yeah.
Gosh. Wouldn't want to be there.
What's the next one you got here? You got two more.
Yeah, we got two more. So that one that you have right there on top is our IV curve trace training. So how to use an IV curve trace, how to interpret the trace, what does it actually do for you, and then troubleshooting steps as a result of that IV curve trace. So IV curve tracing has been around for a long time, almost as long as solar has. It's a great way to determine the health of your system. But a lot of technicians know how to do one. I've worked with a lot of ISPs that are familiar with, we can send a team out and they do the IV curve. But then once they get that information, like, okay, we're just going to hand it to the customer, and what now?
So interpreting the data.
Yeah, so not just how to take it, but how to interpret the data and what does it actually mean for you.
Right there, module 3.
Mm-hmm.
Data interpretation and system analysis.
Yeah, so we have our tracking array that we custom designed and built for our lab environment, so we can do it indoors or outdoors. And we have a combiner box set up so we can wire everything up. We can do different string designs, so different power outputs. So we teach the students how to actually calculate all that. So if I'm doing a different string design or interpreting a different string design, what does that mean? And then how to do the curve. So we have them actually do multiple IV curves. And then we go and take that data and actually interpret that data. So is it shading? Is it soiling? Is it a dead cell? Is it a hot cell? Or whatever the case may be. So they can actually take actions based on that data.
And that's just a 2-day class.
It is.
That's simple. Sounds like an obvious one to go take if you're working on a solar field.
Yeah, it's definitely one of those tests that every site should be doing.
Right. And they just have, so it's always been on the job.
Yes.
Well,
I shouldn't say always.
Yeah,
traditionally, yes. As every company that I've worked with, it's always been grab the senior guy and go teach him how to do it in the field, which I don't ever want to bash on the job training. There's a time, there's a place. Some of the best training I've got was on the job. This is one of those things, especially when you're interpreting, well, if I'm doing an IV curve on the job, I may or may not get to see all of those different data sets that show good, bad, or otherwise.
Right.
Yeah.
Yeah, you might just see the same type of information over and over again.
Right.
All right, very cool. And then we have?
That is going to be our IFC as-built. So issued for construction and as-built schematics or blueprints. So one of the big ones, and this actually came up, it was one of those ones that as a inverter manufacturer technician, I didn't really deal a whole lot with. But we got a lot of requests for how to read these things from our friends in construction, for our O&M technicians. And so we put it together for a company as kind of a trial program to see like, hey, is this what you were looking for? And the feedback that we got was instant and incredible. This was, oh my gosh, this is what all of our technicians need. Because from an O&M perspective, you may not be digging into the inverter or digging into the design of your project. But from a lockout perspective, from a retrofit or a repower perspective, or, hey, we had a ground fault and we have an underground cable run that, burned up. I now have to dig it up and replace that cable. Where do I start?
Right.
Well, you start with those as-built and you say, okay, here's my compaction. Here's what where those lines are physically located. Here's what the length of that line was, what type of cable it was, all of that stuff. And a lot of guys that we were working with just didn't know how to find that information. So we put together the course to teach them how to do it. And overnight, it was just a difference in how they were approaching their work and their quality of work, because they now knew how to actually identify all this information. And not that they were necessarily doing it wrong to begin with, but it's now being able to offer a higher quality service because we actually can understand all the documentation that's available.
IFC again.
Issued for construction.
Issued for construction, as built once it's complete.
Right. So if you figure out, you got money, you want to go build a project, you're going to go to an engineering firm and say, hey, I want to go design this so I can go get it permitted. And that initial set of prints that goes to the construction company is you're issued for construction. They're ready to go build that. All the red lines that happen, during that construction phase, because they, changed manufacturers, had to go through a different supplier for cable, whatever the case may be, had to redesign the project because a kit foxed in was found or something like that.
Right.
The final prints is then your as built, as in this is how we left it, how we built it, how we commissioned it.
We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms. This is coming into more to play. Okay, you said retrofits or when there's a catastrophic event or something like that.
Well, just recently with some of the sites that I've kind of been around, gophers chewing on lines underground and causing, ground faults and fires. Errors in repairs. Hey, we're going out there to do basic DC health and we didn't quite know what we were doing because, we sent, not we, but, the company sent, untrained guys and they set a combiner box on fire, did some damage or whatever. Got to go back to the prints and figure out what was actually installed and how it all gets wired up.
And also a 2-day class.
Yes, also a 2-day class.
Slick. All right. Folks, Rise is on the rise. You got more and more classes coming out of this group. And how are you identifying them? Are you getting the feedback, listening to customers? Is it more casual information?
A little bit of all of the above. As you know, when you're in the industry, you tend to have friends in the industry. So through the customers that we currently train and all of our remote tech support that we do, we've done work with over 100 unique clients. So yeah, based on that kind of feedback of this is what we're seeing in the field today. And it's everywhere from sites that are 25 or years or more old to brand spanking new ones that are getting commissioned and everywhere in between. So we have a really good image of where the industry has been, where it was, where it currently is, and where it's going. So with that, we can kind of see like, hey, this is, we get a really good big picture of where the industry is at and where it's going. So yeah, taking that information and building it out and saying, hey, this is what you guys would actually need, what the modules that are most likely to be, actually sellable. We get a bunch of requests, from clients for kind of niche stuff, hey, I would really love to do this thing. And it's like, well, I'm sure you would, but you're probably the only one that wants to do that. So we're probably going to hold off on building that out just yet. As compared to, okay, we just had about 15 clients ask for this. Okay, this is probably something that needs to be done. We'll go ahead and build it. Combine that with our staff that has an incredible amount of experience, an incredibly diverse amount of experience throughout the industry, wind, battery, solar, for the past 15 years, all of us. We're able to research it, build it, and implement it pretty quick.
Pretty quick.
Yeah.
What is pretty quick? It looks like there's a lot of hours into this.
Yes, it is a lot of hours.
You're only showing me the syllabus. And I know what else is behind the scenes.
So I guess just all of our content has instructor guides, student guides, and deliverable content. So it's not just a syllabus and say good luck, or it's not just a PowerPoint and say good luck. Every single slide that we build essentially has a script on the back end. So it's scalable. So it's not just me because I'm an inverter guy, so I can teach this inverter class. I can hand this to an Anna or a Tyler, and they're going to hit every single point that I hit in the same way that I hit them. So that's the instructor guide, student guide. So the student gets to leave on paper, on a flash drive. It's different for each class that we do, but they have something they can take with them so they can reference back to it. So it's not just oh yeah, I'm pretty sure I heard that in class. No, it's right here on page 57. this is what I need to do. So going back to the not memorization, but where do I go find that information? Also, all of our content from a safety perspective, we tie into the specific instructions. So it's not just Rise saying this because we think that's the right one. But if we said that this is how you're going to be safe, it's because we're referencing this specific OSHA code or this specific NFPA, chapter and verse.
And that's in your guidebooks.
That is all in our guidebooks.
It's a ton of research.
It is a massive amount of research. So to give you an idea, so in the last year and a half, so about 18 months, we finished development of about 6 weeks of deliverable content. So 6 40-hour weeks.
Okay.
And that is, anyone who's ever developed will tell you that is an astronomical amount of time. To do some math, on average, it will probably take about 12 hours of development time for 1 hour of classroom time.
Ooh, interesting.
Yeah, so you don't think of it, right? Oh, yeah. I just sat in class for an hour. That must have taken an hour to develop. No, it takes a lot of time and effort. And that's not including potential research time. So if it's a more advanced topic like advanced troubleshooting, like using an IV curve, well, using an IV curve, there's a lot of procedures out there that'll show it to you. So you just got to build the hands-on practical, build whatever assets you need. But that interpretation of the IV curve takes a lot of time and research to build that out, and then build an effective slide deck that has instructor and student guides and deliverable presentations for that. So more technical stuff could be anywhere from 16 to 20 hours to a 1 hour classroom time. A little bit easier on the safety side where it's, kind of more generic safety where there's a lot of kind of retread of other content. It might take 4 or 5 hours for 1 hour of classroom time. That's what I say. It's about an average of 12 hours.
I follow. And you use the IV curve tracer, like there's information out there, but how much information is there out there on data interpretation and system analysis?
So
I'm guessing you're building that on your own.
Most of it, we're building it on our own. Yeah. Now, there is some information. In fact, if you Google it right now, you can find some information from manufacturers of it, but it's usually just enough to kind of understand the theory. And it's all very much a computer-generated graphic that says, hey, if the curve looks like this, well, it almost never looks exactly like that. So when it looks a little bit different, or you have kind of a unique curve, or even a setup issue where
or watch for how to identify the change.
Right. Yeah. So, and all of that goes into, well, if you don't know what you're doing, I can set up the curve, I can set up the test equipment, hit the test button, but how do I know that was actually an accurate curve? So that's kind of the stuff that we go in there, and how do we actually build out those procedures and that information.
It's a ton of work.
It is a lot of work, a lot of fun, but I've said it many, many times, and I don't even say it facetiously, but we have some of the best in the industry working on this stuff.
You definitely do. I've had the honor of hosting them on this podcast. Yep. It's impressive. Yeah. It's impressive.
And you haven't even, actually, you talked to, so you had Juan on.
Yep. Well, you and John Juan, Tyler was here, and now Anna.
Yep.
Who am I missing?
Mendel Baker.
Well, come on, Mendel.
He is one of the smartest guys I have ever had the pleasure of working with. Just an incredible engineering mind.
All right, cool.
He used to build bomb disposal robots back in the military, so cutting edge technology and actually designing his own stuff. And he was a fire controlman in the Navy for many, many years, worked with me at a previous company. And now we're working together again. And he's an incredible individual.
Dang. Now, do you have other class initiatives that you work on behind the scenes? You don't have to share what they are, but are you always looking to develop? Where are you at in the phase, right? Rolling this out, developing initiatives. You can't do them all at once, right?
Well, we are in fact doing them all at once.
Yeah, I can.
And the age-old saying of we're building the plane as we're flying it, or we're sailing the ship as we're building it. It's very much true. When I first started Rise with John, I was traveling to job sites. It was 100% travel on the job, and it was like there was days where I'm getting feedback from customers. Oh man, it'd be so awesome if we could have this. I'm like, you're right, that is a good idea. So I'd go back into the hotel that night, develop it. The next day, hey, that thing you said would be really cool. Here it is.
Yeah.
And just that kind of mindset of constant improvement, constant innovation. I feel like a lot of the other companies that are really doing it, they have good heart, right? They're trying to build training, they're trying to put out a quality product, and they're succeeding. But they really kind of focus in on the kind of the low hanging fruit, the easy stuff, right? CPR first aid, electrical safety, NFPA 70E, maybe a basic PV 101 that says like, hey, here's all the major stuff and kind of what I know about it. But they don't really want to go too much past that because it's a lot of research. It's a lot of time.
Right.
It's a lot of what if. It's a lot of, I could be wrong. I could say that this is the right thing, but then all of a sudden the industry goes a different direction. And I've seen that a lot with inverter technology, with tracker technology, with string design, for your module strings, a lot of changes. And so that means that we too have to change. It's a very fast growing industry, still in its infancy. So there's a lot of development hours in there that was just like, well, we kind of got to go in new direction.
Continuing to be an independent training company, you're doing more for technicians, and I know you're focused in solar than most companies I've seen in my career. What kind of feedback or observations are you seeing from these technicians that have been through your classes?
One of my favorite things is when I have that really knowledgeable guy. He's a senior technician, whatever that means for his company, whatever job title that is, and kind of has that chip on his shoulder of like, I don't know why I'm here. I already know all this. I'm doing the job. Why are you taking me out of the field? I don't want to sit here. Every single time, without fail, that student comes back and says, I learned something new. I never knew this. And there's always those interactions where, well, I know what I'm doing. Who are you to tell me how to do my job? Well, I'm the guy that was doing your job as well. And not only that, but I've discovered a lot of my bad habits and been able to correct those. And again, it's not me saying it. So it's not me versus you. It's here's all the documentation that shows how we got to this point.
Right.
And with that, it's really cool because almost every single class we learn something new. Now, not necessarily something new that we're going to go and completely from the ground up, redevelop, but new hardware, new test equipment, new tools, new job practices or new scopes, new technology that we just weren't familiar with. And a lot of that stuff we'll just integrate it into the program if it needs to, right? If it warrants the integration. But other stuff is just crazy stories of like, hey, we tried this on this one job because we were, 30 days past our deadline. So we did some cowboy stuff out there and got it done. It's like, okay, well, probably shouldn't have done that. But with that mistake, you actually learn something new that you can implement down the line and actually be more efficient in your job. So I would say, I think not just my observation, but my letter or statement to every single field manager out there, technicians want to be safe. They actually do. I don't know anybody that goes to the job and just like, man, it'd be awesome today, Adam. Trip to the hospital,
I heard that cowboy work pays better, right?
Oh, it never pays. It never pays.
We just talked about that. When did that go? Yeah. You don't get a bonus for that? Instant promotion?
No bonus, no promotion. No, you just have a lot of paperwork on the back end because almost universally I've seen that cowboy work hurts people.
Yeah.
But that feedback I get from technicians is, especially early on in their career, they want to do the right thing. They want to understand. They want to be safe. They want to go home. A lot of the young guys are young fathers, young mothers. They've got brothers and sisters at home. They've got mom and dads at home that they want to go see. But it's almost like the industry tends to break them down of bad habits, bad information, kind of that machismo alpha personality on the job site. I know you know what I'm talking about.
Sure. It pays more.
Yeah, that's what they say. I swear we got stock in doing it wrong sometimes.
Yeah.
But yeah, it's one of those things. I've had a lot of students that like feel like they need to get a gotcha moment with me. I have told many classes my favorite thing to say is I don't know.
Yeah.
And it's not because I'm going to sit here and get all egotistical and how dare you know something I don't. It's like, I get to learn something new today.
Right.
I get to correct something or correct a misconception or, build a better program, build a better procedure or whatever. So yeah, almost every single class we're learning something new. And it's not just from an electrical standpoint, it's safety process or safety mindset from other industries. I've taught guys that were in forestry, guys that were gas and oil, nuclear, guys that were Starbucks baristas. And they bring something to the industry that I didn't bring because that wasn't my background. I used to think I knew a lot about tools. I grew up handy like a lot of guys did,
Yeah.
working alongside with my dad. But I didn't know what every tool was. So once I was able to remove that chip off my shoulder, I realized there's a tool for that. There's a meter for that. Yeah. Oh, there's a better tool for that. There's a specialty tool for that. So one of the things that I do, and it's not specifically a part of our curriculum, is I love just going walking over to our toolbox and opening it up and say, have you ever seen this? Have you ever seen that? Have you ever seen this guy over here? This tool is a game changer. Oh, you're an inverter technician? Here's the 3 tools that changed my life as an inverter technician that I never knew about until way too late.
Wow. I never even thought about that.
Yeah.
It makes sense.
Yeah.
Right. Don't just assume people know.
Yeah. Well, and think about it, you've obviously worked with many technicians, but we have this kind of automatic assumption that every technician knows what's in the tool bag and how to use it. I would almost guarantee if you go to your guys and say, open up your tool bag, what does this do? When would I use it? Why would I use it? What does this do? When would I use it? Why would I use it? And then maybe throw a curveball. Here's this really weird tool that's not a part of your tool bag. Why would we use this thing over here? Mm-hmm. And it's pretty cool.
I've learned about a lot of really weird tools in solar.
Yeah.
Yeah. No, Colton showed me several things I've never even heard of, seen before. Couldn't quite understand how it worked. Yeah.
Well, and it's funny, like, my lesson to the managers, your guys want to be safe if you actually give them the tools to succeed. One of those lessons from the guys like Colton, to the technician is never stop asking questions.
Right.
When he was in class, it was every day, all day, question. And it was funny because, like, after a couple of days, he's like, oh, I'm just going to stop asking questions. Like, no, don't ever stop asking questions. Please ask those questions. And if you ever find somebody that is tired of answering those questions, maybe it's time to find a new room to be in, right?
Sure.
We should always be sharing information. We should always be innovating that information.
That's right. Yeah. Sharing information. What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today. Job satisfaction, for the techs. Mm-hmm. Have you heard any stories? Is it improving their job satisfaction instead of just being forced to go? It seems obvious to me that it would, right? And then might start open up career growth ideas. Mm-hmm. Have you gotten any of those stories come back around? Absolutely.
There's one guy, Tino, still a young kid. I don't know how old he is, but I feel like he's far too young compared to me. But I have trained him probably 5 or 6 times now. And even before Rise, it was just in a previous life where I was training kind of OJT type stuff. And for him, being able to almost maybe every 1 to 2 years for him to come back and just by chance, it's not because he's pursuing specifically Rise training, but just because this company he's working for is like, hey, we want to go send you to this. And it just so happens that Rise has that. We want to send you to this class, just so happens that Rise is going to be the instructor there. And it's really cool to see his career growth. He's just one of many, but it's been really awesome to see guys like that in the industry that I've seen multiple times. And it's like, man, it's really cool to see where you were 6 or 7 years ago, 4 or 5 years ago, 2 or 3 years ago.
I hope the techs are, they're increasing that job satisfaction.
Mm-hmm. Yeah, and job satisfaction is one of those things. I think the guys that are not satisfied move on to a different industry. There's people that get into solar or wind and they're just like, this is not for me. Working outside in the desert, 12 hours a day, not for me. So they kind of go and find something that is for them. But the guys that are in it, I think anytime they get a new skill set where they can improve their job site, and it was one of those things when I was commissioning, there was nothing quite like being able to come home and tell my wife, like, I turned on megawatts today. Like, that is direct utility power to the grid. That's somebody's house. That's somebody's AC. That's somebody's electric stove. That's power that we just did. So I think that satisfaction just comes with the work and being able to learn how to do that work more effectively. It just goes. So I actually got a phone call from a guy I trained a year and a half ago on SMA inverters. And he went from the company where he got the training to another company, and they had some ungodly amount of, inverters down, like 25 inverters down. Site had been poorly maintained. And within a week, he was able to get them all back online.
Okay.
So they're all relatively basic faults, but
Yeah.
using the training that I gave him, he's able to go and fix those things. Job satisfaction.
How cool is that?
Yeah.
How cool is that? Or just to know the why you do something.
Yeah.
Right? We've all been in places in life where we're told what to do and how to do it. And we might be really great at it and never know why until somebody explains it later.
Well, and
how cool does it feel when you finally know why?
Yeah. Well, funny enough, it's actually a part of our new to industry training. A pretty good portion of it is like, this is why we're doing it, not just what to do. Because, square peg in a square hole training, you might as well go on the job and just go put your square peg in the square hole.
Yeah.
But why do I do this? What is the more complete picture? It's my DC health checks. Well, what are you trying to do with that? I know what to do. I know how to write that number down, but what does that number actually mean? What information can I get out of that? And what I've found as far as, indirect feedback, where just listening to technicians and kind of reading in between the lines is, well, I've got 2 or 3 years of experience doing DC health checks, but now I'm in this more advanced troubleshooting and I have no idea what to do. Well, you spent 2 or 3 years of, time getting the information that helps you troubleshoot. But no one ever told them this number means this number means that.
Right.
So how do you go from that maintenance technician that does the square peg in the square hole to a troubleshooting technician that takes that information and does something with it?
I kind of like when you have a technician that's spent some time in the field and they learn the how, right? The what, and then put them into some training.
Yeah.
And it all starts to click.
Yeah.
I've been in situations, and I've seen other people too, where you go to training and you're learning all of this theory and all of this tough information, and then it doesn't click, right? It doesn't make sense until you get to go put it in practice.
Kind of throw ISPs under the bus for a moment. Hey, I got hired on for this scope of work. This is the procedure. I need you to go do this thing. And so the technician does it, and they do it well, and they do it for 1,000 units, whatever the number is. And it's good. That's what was needed to happen. And those guys are some of the coolest ones to talk to because they do have that experience. They do know what a job site looks like. They know how to check in and, do the site orientation and do their safety paperwork and go follow a procedure and do that work. But I've had a few guys that were seasoned senior technicians that come into training and they're like, hey, you just kind of blew my mind a little bit. I've been doing this working on this thing for a decade. And now you actually told me what it was. It's almost like I can now look back on my career and be thankful of how much of an impact I had. I remember there was this one wind technician. He had been doing maintenances for, like I said, 8-9 years. Worked for a company that we both happened to be the coworkers. I was just a trainer. He was a field guy. And so he's got 8 or 9 years climbing turbines, and we come into class and he's just like, hey, I saw you kind of have this little diagram over there of like what the turbine does. I've been a maintenance guy for 8 years. I actually have no idea what a turbine does. Could you show me? And so I was like, yeah. And so I started drawing it up on the board and, going down, and it was started off with the basics of like, hey, here's the high speed shaft, the low speed shaft, your braking systems, your generator and all that kind of stuff. Then, with questions more, it's like, oh, generator, what's that doing? Okay, well, here's what a generator's doing. It's producing power. Then you got a variable frequency drive in there that's going from AC to DC back to AC so we can have nice clean power that goes out to the grid. The grid, what's that? Oh, well, this is what we're actually doing. And ultimately came down to is we're making power for the utility grid so that people can use it. And he just kind of sat back a little bit and was like, wow. And it was like that job satisfaction.
It all clicked.
It's like, yeah, you're actually doing some very important work out there. That piece of maintenance that you're doing for the last 10 years or 5 years, or, you got dirty and grimy and greasy and, it was night work and you're just frustrated at the world.
Yeah.
That maintenance matters, and that maintenance technician is a vital part of turning these lights on.
That's right.
Yeah.
Do you still ever have these moments?
Oh, every week. It's fun. That's one of the biggest things. I don't teach nearly as often as I used to. Now it's just running the company, which has its own challenges, its own fun, its own job satisfaction. But it's always cool to step back into a classroom, even just for a day, and just talk to the guys and say like, hey, I was here. I know what you're struggling with. I know the pains. I would love to hear your story. And just swapping stories. where we've been, what we've seen, what crazy thing we've done, and it's always fun. I always enjoy it.
All right, very cool. I get some of those too. Aha moments, things I didn't understand like my entire life. And then somebody just teaches it in a new way or explains it in my language, so to speak. And man, it feels great.
It does. And it's cool. It's cool to be on the receiving end. It's good to be able to explain it to somebody. And I love this industry. Since the first day I stepped into it, I've met some of the most amazing people, longtime friends. One of my best friends in the industry, Thomas, we talk almost every single day still. He's working out in Idaho right now, freezing. He's sending me text every morning about how freezing it is out there. I'm like, it's going to be rather nice here.
It's still in T-shirts.
Yeah.
Still in T-shirts. Very cool. All right. It's been an interesting year in our industry from a country federal perspective, I guess.
Yeah.
Any challenges that anything affecting you? Or Rise,
absolutely.
rather?
First 6 months of 2025 was obviously, I think for most of the industry, was a really kind of unsettling time.
Yeah.
And it wasn't because it wasn't any specific policy. It was just more of that, well, what is going to happen? New president, new policy, new direction. And so I think a lot of people just kind of put a pause and said, everyone freeze until we figure out what's going to happen. Is the industry going away entirely? Is it going to be, ramped up again like it was under the former the previous president, or is it going to stay the same? And so we were really slow for that first 6 months, and it got a little sketchy for a few days.
Okay.
But no, now we've picked back up, and I think it's one of those things of everyone took a big deep breath and said, yeah, we're going to do just fine. We're going to keep building. And I think it's one of those things that, objectively speaking, solar and battery storage is some of the best things that are out there as far as power production. It's cheapest per watt. It's highly efficient, highly effective, can get permitted quickly, get built quickly. So yeah, I think a lot of companies that like to make money figured out they can make a lot of money doing solar and battery.
Yes, they can. That moment was that OB3 getting signed, and I was waiting for it, but I've also seen these throughout my career, these years up, years down because of federal policy. And all I was looking for was just make the decision.
Yep.
Once you can get a decision, then everybody can make their own individually and move forward. So, regardless of what I understood at the time or know today about OB3, which a bit more, and also understand the items in there that are still unknown to our country, because you write a policy, but if you haven't defined it and written the process to affect it, it's still, in my opinion, unknown. But either way, you just, what's worse than a bad decision? No decision.
Oh, yes.
Right?
It's funny.
You can't sit around being indecisive.
Failing in the correct direction is kind of how I described it, is like, okay, well, I don't know exactly where we're going, but I know it's kind of over there somewhere. So I'm going to go and keep going in that direction. If I have to course correct, no big deal.
Yeah.
But if I don't make any decision, then we're kind of screwed.
That's right.
But I think what's really happening, just kind of technology wise, is with the proliferation of AI. Skynet is coming. But we got to
Tell me more. This freaks me out. Yes.
We got to pave the way for Skynet. Well, a lot of data centers just require a massive amount of power, and there's such a demand on the grid that was never there before. 10 years ago, sure, there was a version of AI, but not in the end user's hands like it is today, your ChatGPTs or Groks or whatever. And so, building data centers left and right, got to have a lot of power.
And how are you going to build what's the fastest power you can build?
Solar and battery, by a long shot.
By a long shot.
Yeah. You figure, now some of it's due to regulation, but that's a whole nother topic to get into. But nuclear can be consistent and scalable and huge and all that.
Nothing fast about it.
Nothing fast
it's the
about
slowest.
it. And nothing cheap about it.
No.
So I see a lot of guys online that be like, oh, nuclear is the wave of the future. And it's like, well, we're going to have to put a pause on the present by, a lot to get to that point. Whereas with solar and battery, we can actually get there in a reasonable amount of time. So.
Right. I forget how long it takes to build, and what X size nuclear gen, but a decade on the small end.
Oh yeah, on the small end, and 20, 30 years on the
for a bigger
end.
One. Yeah.
Whereas, and obviously there's a lot that goes into the size of the project, but solar is 2 to 5 years. from inception to completion.
Right.
Yeah.
From siting, finance, development,
Yep.
making power.
Yep.
Right. But breaking ground and making power, almost the shortest part of it sometimes. Almost the shortest part.
Oh, yeah. A lot of the construction companies I've worked alongside, it is impressive where we were at as an industry 12 years ago to where we're at today, just how much you can build, how fast. It is mind-blowing where a 500 megawatt plant 12 years ago took 2.5 years from breaking ground to our final commissioning. And nowadays, like, that's not even a full 12 months. It's so fast.
Right. So fast.
And it's just incredible how fast these guys can do it and how fast they can throw up some glass and install stuff, and manufacturers can barely keep up, and it's crazy.
All right. So we got through our uncertainty. We had a decision.
Yeah.
You're seeing your customers ramping back up.
Yeah, and a lot of it isn't necessarily ramping back up, yes, where they're coming back and getting training, but I think a lot of them is realizing that regardless of what happens with the industry, you got to train your guys. And we now have kind of historical data to show with some of our longstanding clients that they have better safety records, they have better quality records, so less damage to equipment, less people getting hurt. They can sell more contracts because they have a higher quality technician. And so it's one of those things of, I've had this sales call 1,000 times of like, man, you guys are really expensive. And I was like, you're right. And the only thing more expensive is not going with us.
Ooh. All right. Solid answer. Tough one. Little jabby in there. I don't mind it. Sounds like something ridiculous, I'd say.
But it's one of those things of we know what we have, we know what we're offering, and we've seen it in action over and over and over again. And just like with anything, if you look at the root cause of a safety incident or equipment damage, it almost always goes back in some way, shape, or form to poor training. So it's almost like if I spent the money up front to train this guy, and it might have been a few $1,000s, could be expensive, could be more than that. But the tens of thousands, or some cases hundreds of thousands, or, if you're talking about a severe injury or fatality, millions of dollars are spent. Oh yeah, that few $1,000s up front would have been worth it.
Yeah.
A few $1,000s every year would have been worth it.
Are you advertising that? Do you have those numbers and those stats or fun charts somewhere?
That is what we are the worst about. We don't really do advertising.
Yeah. Chuck them on the website.
Yeah.
Add them to a sticker. No, something. No. Yeah. Okay.
It's something that we need to do. It's just general advertising. But we really suck at advertising. For as good as we are at building our content and delivering it, we are in the opposite direction, just ever so bad at advertising.
Yeah. Well, it's not hurting you.
Yeah, fair enough. Yeah.
It's not hurting you. You guys are growing. Yeah. Seats are filled. New classes being launched. Listening to your customers, giving them what they're looking for.
And I think a lot of that comes down to, I don't like sitting around doing nothing. In fact, no one on our staff really likes sitting around doing nothing. So even if we don't have a class this week, it's like, what can we do to make it better?
Yeah. So. What else is on your mind? I can't go into that OB3 anymore, man. I don't even think I could summarize part of it for you.
Oh, man.
Let's stay away from that darn thing. But.
Yeah, that's fair enough because, politics in general is just a nightmare.
Right.
But what I do find fascinating is how politics and culture affect the industry.
Okay.
And it's just kind of one of those things of, if you think about when you first got into wind, where the industry was at then versus now. I remember sitting just in that building right over yonder, having a beer with a random local and talking about how windmills cause cancer and, the Mojave Desert is only as hot as it is because of all the solar getting installed. And,
okay.
And, just all like the bad memes of misinformation surrounding renewables. So you look at that a decade ago compared to where we're at now, where in the common lexicon is like, oh yeah, no, solar's a way of life, battery's a way of life, EVs are a way of life. Now, me personally, I'm not a big fan of EVs, but this is now stuff that it's like, okay, it's not a matter of should we do it, it's how do we do it? Yeah. How do we do it effectively? And that's one thing I think is pretty incredible, is just how much has changed in the politically speaking. Where if you would have talked to people 20 years ago about transitioning our grid to be more renewable centric, it would have been like, oh no, it's never going to happen. And now it's not about, is it going to happen? It's how do we do it in the most effective way possible, which I think is just a fascinating kind of shift in culture, where both right, left, and center, we're now not saying yes or no, we're saying how.
That's true.
Yeah.
That's true. Yeah, I don't like the political part of it either, but that's part of life. It does offer, checks and balance and diversification. So be happy that, this country concept that we still are a part of figuring out
for the moment,
it seems to be working, I guess.
Yeah, and I'm really excited, again, as the culture shifts, how that also shifts in our discussion around, technologies. Battery storage, obviously, still very much in its infancy, which is incredible to think about. A industry in its infancy is building nonstop everywhere, all the time, and just getting bigger and bigger and bigger. I had the pleasure of commissioning some of the first utility scale battery storage projects a decade ago. And those ones wouldn't even be considered a small site at this point. They're just it's almost like a pet project. Like there's bigger sites that exist in, testing labs that were those ones. But it's also interesting to see some of the groundwork that we laid there from a safety perspective, from a technical perspective, from a control perspective, that are now being implemented on these, multi-gigawatt projects around the world. So really excited to see where battery's coming.
Some of the numbers that I've been hearing, I've been hitting some new conferences. What's better than a gig? Terra?
Yeah.
They're in the terras.
Yes. Yeah. Well, and it's just incredible what's being done. Which, funny enough, talking about development, we're building our battery storage. I actually just had a meeting with Juan Acuna today about how we're going to build out the practicals in our lab and get them done and delivered. Can't wait to come on next time and tell you all about it.
Oh, that's cool. I can't wait to hear that one. All right. Well, we'll look forward to hearing that one, and won't keep you any longer. And thanks for showing up, Steve, and telling us about what's on the rise at Rise and the 4 new classes, Next Step programs.
Well, thank you very much for having me, Adam.
All right. Thanks, buddy.
Yep.